All right, first question, we've got a distance versus time graph. That's the same as like a position versus time graph. Where it is at rest is when the distance or the position isn't changing, so that's at B and also D. When is it changing speed? So changing speed is when it's curved, it's not a straight slope, so E is where it's changing speed. Forward at a constant speed, so straight and up, that's A. Backwards at a constant speed, that's C. We want to find total distance and displacement, so I'm going to mark up each individual. I didn't move anything right here. From 20 to 60, I moved up 40 meters, right? It's just the difference between these. I'm staying at 60, so I'm not moving at all. And from 40 back down to 60 back down to 20, I've moved back another 40. So the total distance traveled, I'm going to add it all up, 0 plus 40 plus 0 plus 40. The total distance traveled is 80 meters. Displacement, I just care start to finish how much your position changed. I started at 0, I started at 20 and I ended at 20, so that my position didn't change at all. My displacement would be 0 meters. The instantaneous velocity at 2 seconds, so 2 seconds is right here. What I don't want to do is just do 40 over 2. Yes, I'm going to use V equals D over T, but I'm going to use it for the entire section, right, not at a point. So I'm going to look at this whole section. This whole section is 40 meters, and the time it took from 1 to 3 is 2 seconds. So 40 meters in 2 seconds gives me a speed of 20 meters per second. Now, similar thing, now I'm looking at 5 seconds. So 5 seconds, I'm going, that looks like it's like 4.5 to 6. So I've gone 40 meters, and that's 4.5 to 6 would be 1.5 seconds. So V equals D over T. Still 40 meters, but now I'm doing this in 1.5 seconds. And divide that, and you get 26.67 meters per second. You'll notice this is a faster speed. It's a little bit steeper in this section than it was here. This is a velocity versus time graph. So where the object is at rest is where your velocity is 0. So you could say point A and F, or you could say none, because there's not really an interval that it stays at rest, just that point and that point. When is it moving forward at a constant speed? So constant speed, you want your velocity to stay the same, so that's BC and DE. Speeding up, you want the velocity to be going up, so that's A to B. Where is it moving backwards? So if you put C to D or E to F, that's actually incorrect. It's just slowing down here. Backwards is a negative velocity, and we don't have any of those. Looking for the acceleration from C to D. So VF equals VI plus AT. VF and VI, so VI would be 4, VF would be 2. And from C to D was 4 to 6 seconds, so that's 2. We're going to subtract the 4 over, that gives me negative 2 equals A times 2. Divide by 2, that gives me acceleration is negative 1 meter per second squared. We've got a roller coaster. It has an initial speed of 15 meters per second. Meters per second tells me this is V and its initial speed, so this is VI. It decelerates uniformly at negative 7 meters per second squared. Meters per second squared has to be an acceleration. Because it's the units for acceleration. Full stop tells me my final velocity is 0, and we want to know how far it traveled, so that means I'm looking for distance. So VI, VF, A, and D. I'm going to use the VF squared equals VI squared plus 2AD. Some of you prefer to use the VF equals VI plus AT, get time, and then plug into the D equals. That's fine. You don't have to. This was a little bit shorter. 0 squared equals 15 squared plus 2, negative 7 distance. So we've got 0, 15 squared is 225. Let's look. Yes. Minus 14d, because 2 times negative 7 is just minus 14. I'm going to add the 14d over. And then now we just divide by 14 to get d by itself. And that gives me a distance of 16 point something, so C. A car accelerates from 4 meters per second, that's my initial speed, to 10 meters per second, that's my final speed, in 8 seconds. How far does it move? So VF equals VI plus AT. 10 equals 4 plus A times 8. These are not like terms. One has an A, one doesn't, so I'm going to have to move the 4 over, subtract it over. That gives me 6 equals A times 8. Divide by 8. That gives me an acceleration of 6 over 8 is 0.75. Now that's not my answer because I want how far it moves. That's distance. I just needed my acceleration first. And now I'm going to use d equals VIT plus 1/2 ET squared. VI is 4. Time is 8 seconds? Yeah. Plus 1/2 acceleration we just found was 0.75. 8 squared. So then now we add, and we get that distance equals 56. This one you're just putting in your calculator. Alright, we want to match this position versus our distance graph with the velocity graph. So what going up straight line means is forward at a constant velocity, right? It's a constant slope, not changing speeds. So a constant velocity should be E. This would be the case for something speeding up, right? Something like this. This distance graph would go with this one, but I had constant speed, so this should be flat. Net force moving on an object, or on an object moving at a constant velocity. Constant velocity is a net force of 0, so that means the forces are balanced, or they equal out. Here we have an acceleration. We're looking for the magnitude. So first of all, if you have acceleration, you can find your net force. So net force equals mass times acceleration. So 3 times 2.5 gives you 7.5. So my net force is this much to the right. That means this force must be greater, right? If I have 10 this way, how big does this need to be to have a total of 7 this way? So let's check out 17.5. See how 17.5 minus 10 would leave me with 7.5? So then F must be 17.5 newtons. We knew it had to be bigger by this much, so I end up with that. A 30 Newton force is required to accelerate a 2 kilogram object at 10 meters per second squared. So this is M, this is A, this is the applied force needed, and we're looking for mu, the coefficient of friction. So first, let's find the force of gravity. Force of gravity is just going to be 2 times 9.8. That gives me 19.6. And my normal force is going to be the same because it's just resting on a surface, so up and down should be the same. I've got this applied force of 30. And then now I also have mass and acceleration, so I can plug into my net force equals ma, mass times acceleration, to get a net force of 20 newtons. Now think about, if I have an applied force of 30 and my net force is actually 20, that means I must have a friction force of 10, because 30 minus 10 would give me 20. And then now that I have my friction force, I just use force of friction equals mu Fn. Force of friction we just said was 10. Looking for mu, normal force we said was 19.6. And then to get mu by itself, we're going to divide. We need to divide the 19.6 over, because that's what we want to cross off to get by itself. 10 divided by 19.6 is going to give us 0.5, yeah, 0.51. 85 kilogram crate is pushed horizontally with a force of 800, so that's my applied force. This is my mass. This is my coefficient of friction, and I'm looking for acceleration. So let's start with our force of gravity and our normal force. Force of gravity is going to be 85 times 9.8. That's a big number. You get 833. Top and bottom. I have this applied force, so FA is 800. And now I need to calculate acceleration. I need to find my missing force first to find the net force. I have a force of friction, that's mu Fn. I know mu, it's 0.2. I know Fn, it's 833. So that gives me a force of friction of 166.6. So once you have that, you can put that in your diagram. Alright, if I have 800 this way, 166 this way, now I just need to subtract to get my net force. It's going to be 800 minus the 166.6. So that gives me a net force of 633.4. And then once I have my net force, now it's just Fnet equals MA. Fnet is 633 equals mass of 85, A. Divide 85 over, and that gives me an acceleration of 7.45. Ito is pulling a 5 kilogram sled through the snow at a constant velocity using a horizontal force of 10. What is the kinetic coefficient of friction? So think about, when we're talking about constant velocity for forces, you need to know that that means balanced. An applied force of 10, so if I have an applied force of 10, and we just said the forces are balanced, that means my friction force must also be 10. My force of gravity is just going to be mass times 9.8, so that's 49, and then it's not falling down, so my normal force will also be 49. And then to find the force of friction, the coefficient of friction, force of friction is mu Fn. We're looking for mu, so this is 10. Mu Fn is 49. Now we're going to divide. We want to divide the 49 over. And that gives me mu is 0.2. A 5 kilogram block is accelerating at 6 meters per second squared on a rough surface by an application of a 50 Newton force. What is the coefficient of friction? So this is very similar to number 3. I have the acceleration, so I'm going to find my net force equals ma, 5 times 6. My net force is 30 newtons. And the acceleration's to the right, so my net force would be to the right. So if I have 50 newtons here and my net force is only 30, that must mean my force of friction is 20 newtons. And then we're looking for coefficient of friction, so we're looking for mu, which tells me to use the mu Fn relationship. First, let's find our normal force, so find Fg. That's going to be 5 times 9.8, which is 49. So Fg is 49, and my Fn would also be 49. Now I'm ready to plug in because I know the force of friction and I know the normal force. Force of friction is 20. Fn is 49. Divide the 49 over, and that gives me a mu of 0.408. If the forces are balanced on an object, that means the object could either be, the obvious one is at rest, right? So it's sitting right here, the gravity and the normal and nothing else balance out, so the forces cancel and it's just sitting there, or it could be at a constant velocity. So something that has an applied force but has an equal amount of friction. It's still moving, but it's not accelerating. That's what we're talking about. A 3 kilogram object has a coefficient, so we've got mass, we've got mu, we've got this acceleration, and we're looking for the applied force. So we'll draw our free body diagram. First, find the force of gravity. That's mass times 9.8, so 3 times 9.8 gives me 29.2, divided by 4. And then my normal force would be the same. I can find my force of friction because I have mu. So force of friction is mu Fn. Mu is 0.4. Fn is 29.4. So that gives me a force of friction of 11.76. I also have the acceleration, so I'm going to use my Fnet equals ma. M is 3, a is 2, so my net force is to the right. So if I have a net force of 6 and this is my friction force, I have to have a force bigger, right? So the net force is to the right, and it has to be 6 newtons bigger, so I'm going to add 6 newtons, and that's going to get me 17.76. And then if you weren't sure whether to add or subtract, just check. 17 this way, 11 this way, yep, that would give me a net force of 6 newtons to the right. Here I have mass, I've got acceleration, so I'm looking for Fnet equals ma. That's 3 times 2.8. That gives me a net force of 8.4. That acceleration is down, so my net force is 8.4 down. Now that's not what I asked for, right? I asked for the force of air resistance for something falling. So think about it. If I have this 3 kilogram object falling, of course it feels the force of gravity. Force of gravity, let's go ahead, is just going to be mass times 9.8. So it's going to give me 29.4. Now my normal force is not going to be equal, right? If it's accelerating down, that means that these did not balance out. So I know I have some air resistance, but it's still accelerating down, so it's not quite as big as the gravity force. So I'm going to find the difference here, and if you're like, why is she subtracting here? She added. Well, we just said that we knew this has to be smaller, not bigger, so that's why I'm going to subtract. So when you find the difference between these, that's 21 newtons. And then let's just double check. 29.4 and 29 up, yep, that would give me a net force of 8.4 down. So this must be the force that's acting on the object upward, or the force of air resistance opposing the motion. All right, we've got a mass and a force, and it has an acceleration of 4. Now if I have twice the mass with the same force, I have less acceleration, right? A heavier object would have less acceleration, so that would be an acceleration of 2, right? A factor of 2 less. Twice the mass is going to be half the acceleration. Something fired at an angle, what's going to be the same throughout? So we know that our x velocity is the same throughout. We also know our acceleration, the negative 9.8, is going to be the same. So yes for A, yes for B. The vertical, the y velocity, is definitely changing, right? Because it's experiencing this acceleration. That means velocity must be changing. It's positive, getting slower. It's 0. It's negative, getting faster. So only A and B are constant. An arrow shot horizontally versus an arrow just dropped from the same height. We know that this should be the exact same amount of time because the only thing that time depends on is the y part. They're following the same y distance. Having a greater x velocity doesn't affect the time at all, only the y would. A baseball player throws a ball horizontally. What do we know about the ball's motion after it is thrown? So vertical is the up and down, or the y speed. We know the vertical speed does not remain the same, so we're going to cross off A and B. We know that y velocity feels an acceleration, right? When we make our chart, on the y part, we have an acceleration that's changing. Think about the y velocity as it falls down is getting faster and faster, so your vertical speed should be increasing. Now your horizontal, right, is the sideways motion, or the x velocity. We know that that does not experience any force or acceleration sideways, so my horizontal speed should remain the same. Y is getting faster, but your x one stays the same. Ranking our speed, so P and R are actually at the same height, so they should have the same speed. Q is going to be slower because you're losing speed on your way up before you gain it again on the way down. So Q should be the least, and then P and R are faster. So Q, and then these two are equal to each other. A golf club hits a golf ball, so it flies off at 40 meters per second at an angle of 60. So as soon as you see these, we know we're going to use VIX is VI cosine of the angle. VI would be 40, cosine of 60. And then VIY, we need to use VI sine of the angle. That's going to be 40 sine of 60. And once we have those, we can put them in our chart. So I have that VIX is, what do I have? VIX is 20, and VIY is 34.64, and the acceleration is negative 9.8. For something going up in the air, we know the y velocity is going to be 0 at the top. That's not at the beginning, so that would be VF is 0. First things first, I'm going to find the time. VF equals VI plus AT, because I have VI, VFA, and I'm looking for time. VF is 0. I want to make sure I'm using only y values, right? It's the whole purpose of making the chart. Minus 9.8t. Subtract this over. Now I'm ready to divide by negative 9.8. And time is equal to 3.53 seconds. Now that's the time it takes to go up, right, until the y velocity is 0. So if I want to find how high the ball will go, this y distance right here, I want to use this time. So I'm going to use the y, or the d equals VIT plus 1/2 AT squared. VI, I already know, is 34.64. Time we just found. Plus 1/2, you have to put the negative 9.8 here. 3.53 squared. And then now this you can just type into your calculator. You don't need to spend time finding each individual and then putting it together. Type it all in at once. And you get that your y distance is 61.22 meters. If you're slightly off, just decimal points off, that is not a concern. If you get close to 61, you're good. Now 6, we're still hitting a golf ball. Now we're hitting it 30 meters per second at 40 degrees, and we want to find how far it goes horizontally. So I'm looking for the x distance. So that's like this part. Oh, you can see this part right here. Still the same idea, right? Find your x and your y velocity. So VIX is going to be 30 cosine of 40. And VIY is going to be 30 sine of 40. So I get my x initial velocity is 22.98. My y initial velocity is 19.28, still have acceleration negative 9.8, and still using VF is 0. Still need to find time first, so VF equals VI plus AT equation, 19.28. Subtract over, divide by the negative 9.8, that gives me your T up is 1.96 seconds. Now I want to find my x distance, right, this right here. I know I'm going to use v equals d over t. I know I'm going to use the x velocity because we're looking at x distance. Now for time, right, we want from the beginning all the way to the very end. That's only the time it takes to get to the top, so I need to double this to get t total, is double that, 3.94. And that's what I want to plug into my equation. And then lastly, to get dx by itself, I multiply this up and I get your x distance is 90.4, but if you have slightly different decimal, no problem. At the point shown, we are describing the vertical, horizontal velocity and the acceleration. You know your vertical velocity, your y velocity is 0 at the top. Your x velocity is the same as it was at the beginning, whatever it was at the beginning. And your acceleration is still going to be negative 9.8, right? The acceleration due to gravity, the force of gravity, isn't going to turn off just because it's at the top. A soccer ball is kicked horizontally off the 22-meter high hill. So that is the y distance, how high up it is. It's going to fall down 20 meters. So it looks something like this. It lands a distance 35 meters away, so that's the x distance. And I want to find this initial velocity. So we, of course, still have the acceleration due to gravity. For a horizontal projectile, your y velocity is starting at 0. Because I threw it horizontally, I did not throw it up or down. So I'm starting from the top, so it's the I that's 0, not the f. Before I can find the velocity, I need to find time. So I'm going to use d equals VIT plus 1/2 AT squared. D is negative 22, 0t, plus 1/2 negative 9.8 t squared. Negative 22, 0 goes away, half of 9.8 is 4.9. Now I need to divide the negative 4.9 over. That gives me t squared is equal to 4.49. That's what t squared is, so I need to square root. That gives me my time is 2.12. Now I have my time, I'm looking for the x velocity, that's going to be v equals d over t. Before, when we were looking for x distance, we had double the time. I do not need to do that here because I'm not going up and down, I'm just falling down. So no need to double it, so v is just the x distance, 35, over the time, 2.12, and that gives me a velocity of close to 17. Alright, for 9 is comparison. The maximum height, we just care about the y. If we look at their y velocities, they have the same y velocity, so they go to the same maximum height. For time, again, we just look at the y. They have the same y, so they have the same time in the air. The faster velocity, so it didn't say x velocity, it didn't say y, so I'm going to look at the total. I know whatever it goes up with, it's going to come down with, so the one that goes up with the most velocity is going to come down with the faster velocity, so that's going to be b. The one that hits the ground first, well, we know when we're talking about time, it's talking about y, so the least y would be b, doesn't take as long to fall down. The one that lands with the slower velocity, so this one, because it has less acceleration, or time to accelerate, same acceleration, less time to accelerate, it's going to have less y velocity, and it also has less x velocity, so that's again b. The one that lands closest is b, because not only is it going slower, it also goes for less time. Something thrown in the air, what happens to the acceleration? We know the acceleration, the vertical acceleration is negative 9.8. It is not changing, it is staying the same the whole time. Now, if you were thinking that it decreases then increases, that's your y velocity that gets slower, 0, and then gets faster again. The acceleration, the rate at which that velocity is changing, is the same. It's negative 9.8 the whole time. A gun backfires when a bullet is fired. What happens to the momentum? Total momentum should always be conserved, stays the same. The momentum of the gun compared to the bullet, so the gun and the bullet, something like this. Now the bullet goes way faster, the gun goes way slower. But that doesn't mean that this has more momentum and this has less, because this has less mass and more mass. They actually should have the exact same momentum because they must cancel out to 0, right? If we're starting with total momentum of 0, it still needs to stay total momentum of 0. The only way that can happen is if you have a positive and negative and they both cancel out, so they're the same, just opposite. 3 kilogram cart moving to the right with a speed of 1. 5 kilogram moving to the left with a speed of 2. So left means I need to put a negative sign there. After the collision, the 3 is going to the left. Again, I need to put a negative with a speed of 1. And I want to find the velocity of the 5. So this is going to be 3 times 1 plus 5 times negative 2 equals 3 times negative 1 plus 5v. I'm plugging into my collision equation right here. 3 plus negative 10. Negative 3 plus 5v, so this just becomes negative 7 equals negative 3 plus 5v. Add this over, did I do that right? You get negative 4? Okay, good. So add the 3 over, that gives me negative 4 is 5v. Oops. To get v by itself, we're going to divide by 5. v is negative 0.8. Alright, we've got mass, we've got initial velocity stopped, and constant force. The impulse, so we know impulse is F delta T. I have F, but I don't have delta T. I also know, right, F delta T is the impulse, it's also equal to the M delta V, so let's use the M delta V side. Mass is 20. Change of velocity, if I was 3 and it went to 0, this just changed by negative 3. So that's an impulse of negative 60. And then whatever I get here, this impulse is going to be the same as the change in momentum. Right? Technically, I actually found the change in momentum, the M delta V. It's just also equal to the F delta T, the impulse. And how many seconds? So now I'm looking for the time. It's supposed to be a delta T. So F delta T equals M delta V. We've already found this side is negative 60. F is 15. So then 15 times what time equals negative 60, divide the 15 over, and that gives me 4 seconds. Now if you get a negative time, that doesn't really make sense. Technically that force would be a negative force because it's stopping. Unbalanced force of 20 newtons is applied for 10 seconds. What is the change in momentum? So 20 times 10, that would give me 200, right? Because the impulse is F delta T, which is also change in momentum. Obviously, M delta V isn't going to work here, so we can use the other side. So 20 times 10 is 200. 2 carts of mass 5 and 1 are initially at rest and pushed apart. If the 5, so let's just draw this. If the 5 then moves westward, so I'm going to make that negative 2, then what's the velocity of this guy? So we've got 5 times 0 plus 1 times 0 equals 5 times negative 2 plus 1v. So we've got 0 equals negative 10 plus v. Add the 10 over, that gives me 1v, which is just v. Right? Dividing by 1, you get the same number. And it makes sense that this one is going faster because it has less mass. Specifically, it has 1/5 the mass, so it's getting 5 times faster. And why this makes sense is because the 1 kilogram has less mass, so it goes faster. A 2 kilogram trawl is going north at 4 meters per second. And we've got a 1.5 that is going south at 8, so I need to make that a negative. And to find the total momentum, right, I'm just going to find the two momentums and add them. So 2 times 4 plus 1.5 times negative 8. 2 times 4 is 8 plus negative 12. That gives me negative 4. The 4 means that it would be like in the south direction, so 4 south. So momentum is mv. If I have twice the mass and I have half the velocity, see how doubling and halving will cancel out, and that would remain the same. A 2 kilogram blob of putty moving at 4 slams into a 6 kilogram at rest. What is the speed of the two stuck together? So I've got 2 times 4, I'm going to make a 0 there, plus 6 times 0 equals 2v and 6v, right? They both share the same velocity because they're stuck together. That's just 0. 2 times 4 is 8. 2v plus 6v, those add because they are like terms to get 8v. divide over, you get a velocity of 1 meter per second. And it makes sense, we knew it had to be slower than 4 because we're just picking up more mass and slowing down. The momentum of the 2 kilogram decreased. That is true, right? It just got slower. That is true because it got slower. The 6 increased. That is true because it got faster. The total momentum was unchanged. That should always be true because it is conserved. And lastly, the 2 kilogram was unchanged. That's not true, right? It was 2 moving at 4, that's a momentum of 8. Now it's 2 moving at 1, that's a momentum of 2. So D, that was not true. 2 cars at the same speed, which has more momentum. So if I have this car coming at 5 and I have this car going at 5, right, the one that has more mass will have more momentum. We can only say that because it's the same speed. And if I have 2 that are the same mass, right, but this one's going way faster, then this one will have more momentum, so the faster one. Again, more mass means more momentum only if the speeds are the same, and more speed means more momentum only if they have the same mass.